On May 13, 2025, the United States Air Force released an official update that caught the attention of the global aviation sector. The announcement highlighted that the path to developing the blended wing body, or BWB, is reaching new heights, a concept that promises to radically transform how we understand aviation. Companies like United, Delta, and more recently Alaska Airlines are injecting millions of dollars into a completely innovative and revolutionary concept in global aviation. But what has drawn considerable attention is how a startup from Southern California is at the forefront of one of the most surprising innovations in aerodynamics of recent decades. Why is this aircraft format, which resembles a futuristic wing more than a traditional airplane, attracting billions in investments, research, and patents? And above all, what is Northrop Grumman's role in this bold bet that already involves prototypes, direct Air Force support, and plans for application on even larger scales?
If you're also passionate about the world of aviation, consider subscribing to the channel and supporting our team.
An airplane without a traditional fuselage, where the wings merge perfectly with the aircraft body, creating a silhouette that resembles a giant stingray. If we had spoken of this concept a few decades ago, they would say it's pure fiction. Today, the concept is already a reality that Jet Zero is building in Long Beach, California. And here's the question everyone has been asking. How does a startup, founded in 2021, intend to revolutionize an industry dominated for decades by Boeing and Airbus? The answer lies in breaking paradigms combined with extensive experience. Tom O'Leary, CEO and co-founder, is no newcomer to technological disruption. He was in Tesla's early years, helping establish the infrastructure of the company that transformed the automotive sector. Alongside him, Mark Page, CTO and visionary behind the concept, carries 35 years of experience in blended-winged aircraft development, having led NASA initiatives in the 90s when he worked at McDonnell Douglas. But Jet Zero isn't just two visionaries with a bold idea. The company has attracted talent from practically all the major aerospace companies in the world. Dan Da Silva, commercial director, is a former Boeing executive and son of one of Embraer's founders. The team includes professionals from SpaceX, Gulfstream, and the U.S. Navy's Air Systems Command. That's certainly no small feat. What differentiates this startup isn't just the assembled talent, but the philosophy that O'Leary calls familiarity with the art of disruption. Unlike previous attempts, Jet Zero isn't reinventing the entire production chain at once. It's building strategic partnerships with industry giants. But what exactly makes the blended wing body concept so revolutionary? The blended wing body isn't a new idea, but a decades-long obsession of aeronautical engineering. Imagine taking a conventional airplane and dissolving the boundaries between fuselage, wings, and tail until everything becomes a single, fluid aerodynamic surface. The result is an aircraft that, viewed from above, looks like a giant wing with passengers and engines harmoniously integrated. The promise is seductive: up to 30% less aerodynamic drag, up to 50% less fuel consumption compared to current commercial jets. To put this in perspective, 50% fuel savings doesn't just mean lower costs. It means the possibility of longer flights with the same amount of fuel. The first BWB studies date back to the 1980s when McDonnell Douglas engineers explored unconventional configurations. NASA funded programs in the 90s, including reduced-scale prototypes. The concept sparked interest in Europe, with Airbus studies, and Bombardier investigated applications in executive aviation. But if the idea is so good, why hasn't anyone built a commercial BWB? The answer reveals monumental technical challenges. First, flight stability. Conventional aircraft are inherently stable. If you let go of the controls, they fly straight. A BWB is aerodynamically unstable, and requires sophisticated computerized systems to maintain flight. Then there's cabin integration. How do you distribute 250 people in a shape that isn't a tube? How do you guarantee windows for everyone? And the engines, where do you place them without creating excessive noise? Airport compatibility is another obstacle. All infrastructure was designed for conventional aircraft. Is the concept viable for airports? But perhaps the biggest challenge is scalability. How do you create a family of aircraft while maintaining aerodynamic advantages? In conventional aviation, you can easily stretch a fuselage. With BWB, changing size means completely redesigning the aerodynamics. This is where Bombardier's crucial contribution comes in. While Boeing and Airbus explored BWB for large aircraft, Bombardier chose a different path, and this may have been the missing step. The Canadian company concentrated efforts on executive aviation, a strategy that seemed less ambitious but proved fundamental. The philosophy was to start small and learn from each challenge. Instead of solving all the problems in a 300-passenger aircraft, they focused on executive jets of 8 to 12 seats. This allowed exploring solutions on a smaller scale, where errors cost less and lessons are more valuable. We actually have a video about this on the channel. For years, Bombardier registered crucial patents related to control systems, engine integration, and modular solutions for different sizes. These patents, many now part of the portfolio that JetZero licensed, represent decades of research. The work revealed something fundamental. BWB doesn't need to be perfect from day one. It can start with 20 to 30% advantages and evolve. This incremental development mentality became part of JetZero's DNA. But what really changed the game was securing support from the world's largest aircraft customer. The U.S. Air Force is providing $235 million over 4 years, expecting to see the BWB jet fly in 2027. This isn't just another military contract. It's a strategic bet on the future of American military logistics.
To understand the Pentagon's interest, we need to think like military strategists. Modern conflicts are decided by logistics as much as by firepower. BWB's unique geometry offers specific advantages. Smaller footprint increases asset availability, operations on smaller runways, and significantly greater cargo capacity. DARPA is also involved. DARPA doesn't fund incremental projects. It invests in technologies that can change the rules of the game. Its participation signals that BWB is seen as potentially disruptive for military operations. The Air Force Department selected JetZero in August for the next phase of the BWB prototype, representing not just technical confidence, but a change in acquisition strategy. Traditionally, the Pentagon worked exclusively with major market players. Choosing a startup represents a new mentality, betting on disruptive innovation even when it comes from smaller players. And this military bet is creating waves that reach commercial aviation, influencing decisions by major industry names. More than 20 suppliers have been selected for the demonstrator scheduled for 2027. Among confirmed partners are Pratt & Whitney, Collins Aerospace, Safran, Thales, and BAE Systems. This isn't a casual list. These are companies betting reputation and resources on technology with real commercial potential. The engine choice reveals careful strategy. For the demonstrator, they'll use 1980s Pratt & Whitney PW2040 engines, seemingly conservative but strategically intelligent. The long-term plan is more ambitious. Future versions will utilize ultra-modern engines like the Pratt & Whitney GTF or Rolls-Royce UltraFan, promising even greater efficiency and reliability. United Airlines made an investment in JetZero in April 2025, signaling real commercial interest. For a major airline to invest in new technology, the economic projections need to be extraordinarily convincing. Perhaps more significant is that these companies aren't just suppliers. Many have become strategic investors. When Collins or Safran invest in a startup, it's not just money, but decades of experience in certification and manufacturing. This is the question that defines this entire story. How can a 3-year-old company compete against corporations that have dominated aviation for decades? The answer begins with an uncomfortable reality. Success can be an obstacle to innovation. Boeing and Airbus have billions invested in existing lines, thousands specialized in current technologies, and commitments to airlines that expect evolution, not revolution. For Boeing, developing BWB would mean admitting their current line is obsolete. For Airbus, it would be recognizing that decades of refinement were a dead end. No company can make this transition without massive financial turbulence. Jet Zero doesn't have these burdens. It can build from scratch, optimized for BWB. It doesn't need to maintain compatibility with existing tools or convince shareholders about abandoning profitable lines. This dynamic isn't new. Tesla didn't beat GM and Ford by being better at conventional cars. It created a new category. SpaceX didn't surpass Boeing by improving existing rockets. It revolutionized with reusability. Jet Zero follows the same playbook. Innovate where giants cannot. Air Force support is crucial, but not just for the money. It's technical validation. The Pentagon doesn't invest $235 million without rigorous analysis. If American military experts believe BWB is viable, that carries weight with investors and commercial customers. The competitive environment has changed. Aviation faces unprecedented environmental pressures. Countries are implementing carbon taxes. Airlines face pressure from conscious consumers. An aircraft 50% more efficient isn't an advantage, it may be a survival necessity. The company announced a $4.7 billion investment to build its first plant in Guilford County, North Carolina. This isn't a prototype facility, but a factory for commercial-scale production. When Jet Zero's BWB demonstrator takes off in 2027, it won't just be an experimental aircraft, it will be the materialization of decades of dreams and persistence. That moment will represent the transition from academic idea to commercial reality that could redefine aviation. The Air Force will likely be the first real-scale BWB operator. Military operations can tolerate limitations that the commercial market wouldn't accept, providing time for refinement. But the real impact will come when the first commercial BWB aircraft enter service. Passengers will experience a completely new way of flying. Spacious cabins, panoramic views, lower noise levels. Airlines will see drastically reduced costs. Northrop Grumman's bet represents more than investment. It's a declaration that the future will be defined by those who can think beyond current limitations. For decades, aviation evolved through incremental improvements. BWB represents fundamental change in the physics of flight. If Jet Zero transforms vision into reality, it will be remembered as the company that proved startups can lead technological revolutions. More importantly, it will show that the future doesn't belong to those with vast resources, but to those with clear vision and courage to pursue the impossible. The sky is no longer the limit when you recognize the way we've always flown may not be the best. Jet Zero is betting everything on this premise. In 2027, we'll know if they were right. And if they are, we'll be witnessing not just the birth of a new aircraft, but the beginning of a new era in aviation. The sky revolution may be closer than we imagine.